Intersection of two open sets in R is an open set in R. Proof. Let S1 and S2 be two open sets in R. We have to show that S1 intersection S2 is an open set in R. Case 1. Let S1 intersection S2 equal to 5. That is, S1 and S2 have no common elements. Then we know phi is an open set. Hence, S1 intersection S2 is an open set. Now, case 2. Let S1 intersection S2 is non-empty, not equal to 5. That is, they have common element. Let X be an arbitrary element of S1 intersection S2. Now, this implies X belongs to S1 and X belongs to S2, since this is intersection. Now, since S1 is an open set, and we get X belongs to S1. So, by the definition of open set, X must be interior point of S1. X is an interior point of S1. What is the definition of open set? A set S is said to be open if every point of S be its interior point. Now, S1 is an open set and X is a point of S1. So, X must be interior point of S1. Now, by definition of interior point, since X is an interior point, so by definition of interior point, then there exists some delta 1 greater than 0 such that delta 1 neighborhood of X contained in S1. This is a definition of interior point. Since X is an interior point of S1, so there is some delta 1 greater than 0 such that delta 1 neighborhood of X contained in S1. Similarly, since S2 is an open set and X belongs to S2, so X is an interior point of S2 by definition of open set. So, X is an interior point of S2. Now, since X is an interior point of S2, by definition of interior point, then there exists some delta 2 greater than 0 such that delta 2 neighborhood of X contained in S2. This is the definition of interior point. Now, why choose different delta? That is delta 1 and delta 2. Because S1 and S2 are two different sets. So, choose different delta. Now, let delta equal to minimum of delta 1 and delta 2. Then, we get delta neighborhood of X contained in delta 1 neighborhood of X and delta neighborhood of X contained in delta 2 neighborhood of X. Suppose let delta 2 greater than delta 1, then this is delta 1 neighborhood of X since delta 2 greater than delta 1, this is delta 2 neighborhood of x. Now delta 1 neighborhood of x contained in delta 2 neighborhood of x. We take delta equal to minimum of delta 1 and delta 2. So here delta equal to delta 1 because delta 2 greater than delta 1. So just we write here, that is nx delta contained in nx delta 2, and we obviously know that delta 1 neighborhood of x contained in delta 1 neighborhood of x, a set contained in itself. Similarly bhabe neighborhood contained in itself. Now we write in the left that delta 1 equal to delta, that is neighborhood of delta neighborhood of x contained in delta 1 neighborhood of x. So we get this and this, just we write here these two. Similarly, if we take delta 1 greater than delta 2, same result will also hold. We show for this. Similarly, you can show for delta 1 greater than delta 2, these two. Now this is contained in S1 and this is contained in S2. So obviously delta neighborhood of x contained in S1 intersection S2. This implies, and this shows that x is an, this shows that x is an interior point of S1 intersection S2 by the definition of interior point. Since delta neighborhood of x contained in S1 intersection S2, so x is an interior point of S1 intersection S2. Now since x is arbitrary, x is an arbitrary point, of S1 intersection S2, so every point of S1 intersection S2 B is interior point. Now what is the definition of open set? A set S is said to be open if every point of S B is interior point. Now every point of S1 intersection S2 B is interior point. Hence S1 intersection S2 is an open set. We prove this theorem. If you like this video, please share, subscribe and comment.